Hello and welcome back to our channel. Today we're going to talk about one of the most intriguing and mind-bending topics in physics, traveling at the speed of light. Ever since Albert Einstein developed his theory of relativity, scientists have been fascinated by the idea of traveling at the speed of light and its implications for the nature of time, space, and matter. So, buckle up and get ready to go on a journey through the wonders of the universe. To understand what happens when we travel at the speed of light, we need to first understand what light is and how it behaves. Light is a type of electromagnetic radiation that travels through space in the form of waves. It moves at a constant speed of 299,792,458 meters per second in a vacuum, which is known as the speed of light. This speed is so fast that it's hard to even fathom what it would be like to travel at that speed. According to Einstein's theory of relativity, as an object's speed increases, time slows down. This means that time would appear to be moving slower for us than it would be for someone who is standing still. As we approach the speed of light, time would slow down more and more until it would essentially stop at the speed of light. This phenomenon is known as time dilation. Time dilation has been observed and measured in experiments involving high-speed particles, such as subatomic particles and cosmic rays. The experiments confirm that the faster an object moves, the slower time moves for it. At the speed of light, time stops completely, which means that if we were able to travel at the speed of light, we would essentially become frozen in time. Another consequence of traveling at the speed of light is that our mass would increase infinitely. As an object's speed increases, its mass increases as well. At the speed of light, our mass would become so great that it would take an infinite amount of energy to keep us moving. This means that it's impossible for anything with mass to travel at the speed of light. This concept is encapsulated in Einstein's famous equation E equals mc squared, which describes the relationship between energy and mass. However, even if we could somehow overcome the problem of infinite mass and travel at the speed of light, we would still encounter other strange and mind-bending phenomena. For example, as we approach the speed of light, the length of objects in the direction of travel would appear to shrink. This phenomenon is known as length contraction. Additionally, colors would appear to shift towards the blue end of the spectrum. This is because the faster an object is moving, the more its light waves will be compressed, causing the light to appear bluer. But what about light itself? Since light has no mass, it can travel at the speed of light without any problems. This is why light is able to travel vast distances through space without slowing down. In fact, the fact that light always moves at the same speed, regardless of the observer's frame of reference, is one of the fundamental principles of Einstein's theory of relativity. Finally, it's worth noting that while traveling at the speed of light is impossible for massive objects, it is still possible for massless particles, such as photons. In fact, photons are the fastest things in the universe and are essential to many processes in nature, such as photosynthesis and vision. In conclusion, traveling at the speed of light is one of the most fascinating concepts in physics. Although it's impossible for anything with mass to reach this speed, the implications of what would happen if we could are truly mind-bending. Time would slow down, our mass would increase infinitely, and objects in the direction of travel would appear to shrink. However, light itself, being massless, can travel at the speed of light without any problems. The fact that light always travels at the same speed, regardless of the observer's frame of reference, is a fundamental principle of Einstein's theory of relativity. It's worth noting that while we may never be able to travel at the speed of light, this doesn't mean that the concept is purely theoretical. As mentioned earlier, high-speed particles such as cosmic rays can travel at a significant fraction of the speed of light, and we can observe the effects of time dilation and length contraction on them. Furthermore, scientists continue to push the boundaries of what's possible with technology, and who knows what breakthroughs might be made in the future that could change our understanding of what's possible. So, what would it be like to travel at the speed of light? Unfortunately, we may never know for sure. But by exploring the implications of Einstein's theory of relativity, we can gain a deeper understanding of the nature of time, space, and matter, and the mysteries of the universe. That's all for today's video. We hope you enjoyed this exploration of the secrets of traveling at the speed of light. If you found this video informative and interesting, please consider giving it a like and subscribing to our channel for more content like this. Until next time, keep exploring the wonders of the universe.